first problem, we are to graph the solution set of the following linear inequality. 4x plus 5y is less than 40. The very first question we have to answer down here is whether we have a solid or a dashed line for our boundary. Since it's less than, we have a dashed line. The next thing that they're going to ask you to do is enter 2 points that are on the boundary line. The easiest thing to do there is your x and your y intercepts. So if I plug x equals 0 in, that disappears. I'm left with 5y equal 40. Divide both sides by 5. Y is equal to 8. So my ordered pair there will be 0, 8. And that's right there. I'm going to go ahead and graph it. The Hawk software will graph it automatically for you, which is nice. If I try y equals 0, that piece goes away. And that leaves me with 4x equal 40. Divide both sides by 4, x equals 10. So that ordered pair is 10, 0, which is over here. And it's a dashed line. I'll do my best to draw a straight line. And then finally, it wants you to select the shaded region. Now this is a little tricky because it doesn't show the A or the B. I'm going to put A up there and B down here. If you can, it's always best to test the origin, which I can. When I plug 0, 0 into this original equation, I have 0 less than 40, because that becomes 0 and that becomes 0. And 0 is actually less than 40, which means I would shade below, which in this case would be region B. This next problem, we need to graph the solution set of the following linear inequality. 8y minus 6x is greater than. Our next example is asking us to graph the solution set of the following linear inequality. 8y minus 6x is greater than 24. Once again, first question, dashed or solid. Strictly greater than means that I have a dashed line. The next thing I need to do is determine 2 points that are on the boundary line. I like to do x equals 0, which basically means I have 8y equal 24. Divide both sides by 8. Y is equal to 3. So I have the ordered pair 0, 3, which I graphed right there. The other one, I plug y equals 0 in, which gives me negative 6x equals 24. Divide both sides by negative 6, x equals negative 4. So that ordered pair is negative 4, 0. Graph that point there. Now I'll sketch my dashed line. And I will put A up in this corner and B down here. I'm going to test the point 0, 0. Is 0 greater than 24? The answer is no. So I will shade the half plane that is where the A is, and that's my region. Our next one, 5y plus 30 is less than or equal to 3x. First question, solid or dashed line. We have less than or equal to this time, which means a solid line. The next thing, it's asking us to enter 2 points that are on the boundary line. Once again, I can try x equals 0 and y equals 0. When I plug x equals 0 in, that leaves me with 5y plus 30 equals 0. I'm going to have to subtract 30. 5y equals negative 30. Divide by 5, y equals negative 6. My first ordered pair will be 0, negative 6, which is down here. Then I'm going to try y equals 0, which gives me 30 equals 3x. Divide by 3, x equals 10. So that point is 10, 0, which is over here. I have a solid line. So there's my line. I'm going to put A up here and B down here for my regions. I'm going to test the point 0, 0. Is 30 less than or equal to 0? And the answer to that is no, which means I will shade the lower half plane, which is B. The next problem has y greater than or equal to 4. This is a special line because I am missing the x-coordinate. Y greater than or equal to 4 is going to be a horizontal line at 4. Now, greater than or equal to means I have a solid line. I'm going to come up here, draw my solid line at y equals 4. When you talk about points that you draw, it doesn't matter what your x-coordinate is. So it could be 0, 4, 1, 4. I'm going to put A above, B below. I can test 0, 0 still. Is 0 greater than or equal to 4? The answer is no. So I will shade above, which is region A. This time I have 8y less than or equal to negative 6x plus 48. Less than or equal to means solid line. And I'm actually going to put this in standard form so that I can do the x and y intercepts a little bit more easily. So I've just added 6x to both sides. That leaves me with 8y plus 6x less than or equal to 48. When x equals 0, I'm going to have 8y equals 48. Divide both sides by 8. Y equals 6. So my point there is 0, 6. When y equals 0, I'm going to have 6x equals 48. Divide by 6. X equals 8. So there my point is 8, 0. Put that right there. Try to draw a solid line through those 2 points. I'm going to test the point 0, 0. Is 0 less than or equal to 48? Yes. Oh, and I forgot to say, A is up there, B is down here. So that means I'm going to shade the half plane that is B. For this one, we have 2 times y plus 5 less than negative x. I'm going to go ahead and determine whether I have a solid or dashed line. And in this case, less than is dashed. And then I am going to go ahead and find 2 points that would be on the line. And I think I'm going to do the distributive property and try to simplify this a little bit to begin with. 2 times y is 2y. 2 times 5 is 10. That is less than negative x. I'm going to subtract 10 and add x. That's going to leave me 2y plus x less than negative 10. So when I look at this problem, if x is 0, that leaves me with 2y equals negative 10. Divide by 2. Y is negative 5. So one of my points is 0, negative 5, which is right down here. If I let y equal 0, that leaves me with x equals negative 10. So I've got the point negative 10, 0, which is right here. And it's a dashed line. Region A is going to be up top, region B down at the bottom. I'm going to plug in the origin, 0, 0. Is 0 less than negative 10? Answer to that is no, so I'm going to shade the half plane at the bottom, which is B. This problem, we have 4x plus 2y all over 4 greater than 1. I'm going to start by multiplying both sides times 4, so I don't have that fraction anymore. That's going to leave me 4x plus 2y greater than 4. Since it's strictly greater than, I have a dashed line. When I try x equals 0, I have 2y equal 4. Dividing by 2, y gives me 2. So one of my points is 0, 2. And when I plug y equals 0 in, I have 4x equal 4. Dividing by 4, x is equal to 1. So that point is 1, 0, which is right here. And my attempt at a dashed line. Region A is going to go up there, region B down here. I can still test my origin. There's my origin, 0. So is 0 greater than 1? Answer to that is no. So you're going to shade the half plane that's on top, which is A. Here I have the inequality, negative 7y plus 9x greater than or equal to negative 7y minus 36. And I'm going to try to clean this up a little bit, and I'm going to move the 7y that's on the right over to the left, which means I'm going to add 7y to both sides. Negative 7y plus 7y is 0, and then I have 9x greater than or equal to negative 36. I'm going to take that one step further, divide by 9 on both sides, giving me x is greater than or equal to negative 4. So this time we have another special line. This one is a vertical line. And greater than or equal to means solid. It's going to be a vertical line through negative 4. And we can pick any points that we want to on this one, as long as the x-coordinate is negative 4. So negative 4, 1, negative 4, negative 4. I'm going to put A up here, B down here. When I test the point 0, 0, here is 0 greater than or equal to a negative 36. And the answer is yes, which means I'm going to shade over here in region A, the side that has 0, 0 in it. The next one is 5 minus 6y greater than 26 minus 7x. Once again, I'm going to clean it up, so I'm going to subtract 5 and add 7x to both sides. That's going to leave me with 7x minus 6y greater than 26 minus 5 is 21. And when x is equal to 0, I have negative 6y equal 21. Divide both sides by a negative 6. Y equals negative 21 over 6, which reduces to 7 over 2, negative. So 0, negative 7 over 2. Oh, I did forget to say whether we had a solid or dashed line. Greater than means dashed. All right. And again, when you put these numbers in HAWX, it graphs it for you, so don't worry too much about that. Negative 7/2, though, is negative 3.5. So I'm going to be 1, 2, 3, right about here. Okay, and then when y is equal to 0, we have 7x equals 21. Divide by 7. Both sides, x equals 3. So that point is 3, 0. So go 1, 2, 3, 0. Have a dashed line. We put A up there, B down here. If we test our origin, we end up with, those are zeros. So is 5 greater than 26? The answer to that is no, so we're going to shade the lower one, which is B. Here we have 7x greater than or equal to 7y minus 49. Oh, solid or dashed, greater than or equal to means solid. I am going to move the 7y to the left by subtracting it from both sides. It gives me 7x minus 7y greater than or equal to a negative 49. And if x equals 0, I have negative 7y equals negative 49. Dividing both sides by negative 7, y ends up being 7. 1 point then is 0, 7. If I let y equal 0, I have 7x equals negative 49. Divide both sides by 7. X equals negative 7. So this point is negative 7, 0, which is right here. I have a solid line. I'm going to put A up here and B down here. If I test 0, 0, is 0 greater than or equal to a negative 49? The answer is yes. So I'm going to shade the half plane below here that has 0, 0, which in this case is B. This is our final example problem. 7x plus 5 is less than negative 7y plus 5. Again, cleaning it up a little bit, I want to add 7y to both sides, and I want to move this 5 by subtracting it. That gives me 7x plus 7y less than, and then 5 minus 5 is 0. All right, less than strictly means it's a dashed line. This one's going to be a little bit different. I'm going to have to stray from my original plans because you'll notice if I start out by trying to find my points and I put x equals 0 in, I'm going to end up with 7y equals 0. So when I divide both sides by 7, y ends up being 0. So my origin is actually on my line. All right, it's not that big of a deal. I'm going to just choose another value for x. I'm going to just go with 1. When x is 1, I have 7 times 1 plus 7y equals 0. That gives me 7 plus 7y equals 0. Subtract 7. 7y equals negative 7. Divide by 7, y equals negative 1. So this point is 1, negative 1, which is right here. So try my dashed line. All right, I'm going to put region A up there, region B down here. And you can pick any point, so we'll just pick 1, 1. That's usually easy enough. When I plug 1, 1 in there, that gives me 7 plus 7. And is that less than 0? The answer is no. So we're going to shade the lower half, which is B.